Hey guys, in this session we are going to learn about an important concept called clustering factor of an index. Okay, so this clustering factor is not a feature of Oracle database. Okay, it is one of the statistics or the characteristics of an index. Okay, so if we just want to identify the character of a person, right? So we will be identifying the person with the help of the person's nature, right? Whether he is good or bad. We will be having some indicators, some statistics. Based on that, we judge the person based on the characteristics. So likewise, we determine the performance of a particular index with the help of the clustering factor. Okay, so this is a statistics which is related to specifically to index. Okay, it is not related to any other objects. Okay, so it helps the optimizer to estimate how efficiently an index can be used to retrieve rows from a table, right? So how frequent or how many number of IOs will be used when we use an index can be determined with the help of clustering factor. So if the clustering factor is good or low, then less IO will be required. If the clustering factor is high or bad, then more number of IOs will be required. Okay, it is an important concept for understanding the query performance and tuning the indexes. Okay, so what is a clustering factor? So this clustering factor is a statistic which indicates that how closely the order of rows in the table matches the order of entries in an index. Okay, so let me come to the diagram. So here we can see two diagrams, one with good clustering factor, one with bad clustering factor. So here the clustering factor is low. Low means good, okay, high means bad. So here if you see, there are this is root block, this is branch block, and this is leaf block, just assume, and we have a table. Okay, and these are the index blocks which are storing the entries of the data. Okay, so we have a pointer, right? With the help of the row ID, the index will identify the address of a particular block, right? So all these pointers will be pointing to the table block. Okay, so if all these pointers are pointing to the blocks as per the table order, right? So if the index is storing all the index entries in the form of table order, say for example, so this block is 1, 2, 3, 4, 5, 6, 7, 8. Okay, if the index is also having the same order of the table, okay, so this pointer will be pointing to this one block, this pointer will be pointing to second block, this pointer, third pointer will be pointing to 3 block. Likewise, the number of index entries will be equal to the number of blocks which are stored on the data file. Okay, that is good clustering factor. What is bad clustering factor? Say for example, the same example I will give you, 1, 2, 3, 4, 5, 6, 7, 8. So here in index the entries are not in a proper way. So say for example, 1 is here, or we can say 1 is here, 2 is here, 3 is here, 4 is here, 5 is here, 6 is here, 7 is here. So the index entries will not be in an ordered way, it will be in a random way. Either the data which is stored on the table will be in a random way, so we can say it will be like this: 1, 2, 3, 4, 5, 6, something like this. Okay, always index will be in a sorted manner, but if you see, when the index entries are pointing to the table, the order of data will be random. So 1 will come here, 2 will come here, 3 will come somewhere here. So now if you see, it looks quite clumsy, right? For identifying the data itself, it is clumsy. So imagine if in a real-time system, when Oracle is scanning millions of rows, how Oracle will be scanning the data. It will be randomly scanning the data. If the this is where the clustering factor come into picture. So if the clustering factor is bad, then Oracle has to locate the particular block on the table with some difficulties. That's where the number of index entries will be equal to the number of rows on the table. Okay, that's what mentioned here. This line is very important. How closely the order of rows in a table matches the order of entries in an index. So we cannot do anything. Once we create the table and insert the data, we cannot change the order of rows, right? Unless until we do some move operation, right? So we are moving the table to a different table space, something like that, right? So this is where the clustering factor come into picture. A low clustering factor is good, okay, and it means that the rows in the table are physically stored in the same order as the index entries, right? Again, I mentioned that the rows in the table which are physically stored cannot be controlled. We cannot manually put each and every rows in the order of the index, right? Automatically the order will be decided by Oracle itself, right? We just create the table, we don't determine the order of rows, right? So only fewer block reads are needed when using the index. So you can see this example here. If you see, only one block is red, one or two blocks, only two blocks are red. The arrow marks are pointing to only two blocks, but here if you see, these arrow marks are pointing to multiple blocks. So multiple block reads will cause multiple IOs, which will cause multiple which will cause us more resource usage, so which will cause performance issue. Okay, high clustering factor is bad, so it means that the rows are scattered randomly in relation to the index order, leading to more block reads. Okay, generally you have to keep this formula in mind. Okay, number of blocks in the table should be equal to clustering factor. This means good. If number of rows are equal to clustering factor, then the index is having a bad clustering factor. We need to do some we need to identify some solution and do something to avoid the performance issue. Okay, so here is an example. Suppose a table has 1 million rows stored in 10,000 blocks. Okay, so if the clustering factor is around 10,000, that is good. So I already mentioned this formula, right? Number of blocks in table should be equal to clustering factor. So here the number of blocks are 10,000 and clustering factor is also equal to the number of blocks. This is good. It means the index is closely matching the table's row order. Here the row order matters. Okay, if the table row order is if the table row order is correct as per the index entry, or if it is equally entered in the index as per the table's row order, then the clustering factor will be equal to the number of blocks. But if the clustering factor is 1 million, so here if you see, clustering factor is equal to the number of rows. So if the number of rows are equal to the clustering factor, then that is poor. Each index lookup likely accesses a different block. Okay, so this is the query to check the clustering factor of an index. Okay, so when we need to check, okay, always we cannot say that if clustering factor is having some value, it is bad. But whenever we are facing a performance issue, or whenever we are facing we are seeing the million rows, the number of rows equal to the clustering factor, then we need to take some action. So if the clustering factor close to the number of rows in the table, you are experiencing slow performance with index based queries. Definitely if the clustering factor is bad we will get a performance issue. Okay, because a lot of physical IOs will be involved. Physical IOs are very expensive, so the index may not be efficient. So optimizer automatically may ignore that index, rather than it will go for a full table scan instead of using an index. So these are the recommendations for improving the bad clustering factor, but still we cannot completely eradicate clustering factor. Okay, so once the table is built, it will be built throughout the life cycle of the database, unless until we drop it or we cannot move it in a production system, right? So this is one of the solution, reorganizing the table, which will reorganize the rows. But in a production system, this is not feasible. And rebuilding the table so that rows are stored in the same order as the index. Rebuilding the table is also not feasible. So we can create a backup table and insert the original rows from the original table, and then rebuild the original table, again rename the backup table. So that's not feasible, right? So once the clustering factor is bad in a production system, it will be very challenging to overcome. Okay, so we cannot avoid as well. Okay, so other solution is to use index organized table, IoT, if the data access pattern relies heavily on one index. So this is also specific to one use case, right? Why a clustering factor of an index becomes bad? Because there may be multiple modifications on the table, multiple deletes, inserts, updates, and index blocks also will become index entries also need to be changed. The pointer needs to be updated. If we update, then there will be row migrations from one block to another block. So during those cases, definitely the pointer needs to be changed. So that's where the bad clustering factor happens. Okay, so we can try using IoT indexes. So we already learned about the types of indexes, right? So we can try creating an IoT index when the use case is specifically for the access pattern, data access pattern, that is relying on only one index. Because IoT index will not use row ID, right? Row ID will be avoided. All the data will be indexed in the IoT itself. So the opposite is the heap organized table, but heap organized table is something different. IoT index is something different. Okay, so heap organized table, we create B-tree index, bitmap index, and all these stuffs, right? So coming to the fourth solution, we can use table clusters for specific use cases while multiple tables are frequently joined. So this is only feasible for clustering the tables, but in real time, clustering table is itself a different or a specific use case, right? We cannot use clustering table for every applications. Okay, so this is the importance of clustering factor. Okay,